Hello, this is Unzadani. Welcome back to the second component or the last component of polysaccharides. So here we are going to talk about polysaccharides, and polysaccharides we have the energy storage ones and those that are just the components of structures. So polysaccharides from the word poly. So this means that these they are made up of many monomers, and these monomers they have to be 10 and more monomer units. So here you have to be specific. Here they have to be 10 or more, because if they are less than 10, that means you are going to have something else, and we need to know that mm, monosaccharides have one monomer unit. Then we have disaccharides. These have two monomer units. We also have what we call oligosaccharides. Oligosaccharides. So as you can see, so this means that these just range from 3 to 9 monomer units. These are oligosaccharides. Then lastly we have polysaccharides, which are the ones that are of our interest for this video. So polysaccharides. So these have 10 and more. 10 and more monomer units. Ten and more monomer units. So let's now look at some of the characteristics. So these polysaccharides, they are not sweet, non-sweet. They are not sweet to taste. Then they are insoluble in water. Insoluble in water, or they may be slightly soluble sometimes. Or slightly soluble. So they are formed by condensation. By a condensation reaction, which is the same as dehydration, where you raise a water molecule is given out between many monomer units. Ten and more monosaccharides. So you've seen, so this one, it has to be 10 or more monosaccharides. The condensation of these reactions is what give us what we call a polysaccharide. So these polysaccharides may be energy storage, maybe in the form of energy storage, which are starch and glycogen. Of course, starch is for plants, but glycogen is the one for animals. Or it may be part of the structures or structural component, such as cellulose, cell walls, and chitin in the shells of organisms. So this one is cellulose in cells, in shells of organisms. Organisms. So starch and glycogen are suitable as storage molecules because they are insoluble. Let's write it somewhere so that you don't forget. So you said starch and glycogen are storage molecules because one, they are insoluble in water. That means they can be stored. They are not dissolved in water. That means they can be stored. Unlike the monosaccharides, which are soluble in water, whereby they can be transported, they are easily used by the cells immediately they are formed. So they are also made up of fibers. Of fibers. And thirdly, they have high tensile strength because of the fibers. They have high tensile strength. So let's look at starch now as one of the polysaccharides which is used as an energy storage. So what is the starch? This is a polymer. A polymer is just a molecule of many monomer units or monosaccharides. So a polymer of alpha glucose. Monomers. Alpha glucose monomers, which first join to form maltose. Form maltose. Remember, we looked at maltose. So this is a disaccharide of two glucose monomers. So starch is insoluble in cold water. It's insoluble in cold water because it's long with many glycosidic bonds between glucose monomers. It is long with many monomers joined by glycosidic bonds. It is joined by glycosidic bonds, and this may also be because it is tightly packed. That's why it is insoluble. So let's now see the two components of starch. So we have one which is amylose. So this amylose has a straight chain with thousands of the monomer units of glucose which are linked by so straight chain. So joined by 1,4 glycosidic bonds. So the main point to get here, it is a straight chain because there is a difference when we go to amylopectin. So this one, it coils into a helix forming a compact shape and coils into helix to form compact shape. That's the thing you need to know about amylose. So it constitutes about 20 to 30% of starch. So that is amylose, 20 to 30%. So now let's look at the second component of starch. which is amylopectin. So amylopectin. So this is the second component of starch. So this one is similar to amylose, except that has additional it has got additional branches. These branches are formed because of the glycosidic bonds, which are alpha 1 to 6 glycosidic bonds or linkages. So you've seen the difference. So the first one has got 1 to 4, which is amylose, has 1 to 4, but for this one has an additional one, which is alpha 1 to 6. And the chains for this one are shorter. Are shorter. The chains are shorter. So this one constitutes a high percentage, about 70 to 80% of starch. So you've seen, so this means that amylopectin is what makes a high percentage of starch. So most of the starch is made of amylopectin, which are just the chains, just similar to amylose, but these they have additional branches which are formed by alpha 1 to 6 glycosidic bonds, because in amylose we just learn to say they just have 1 to 4 glycosidic bonds. So let's look at an example of amylose, also how this amylopectin is formed, so that we can see the differences. So you will just look at the structure of amylose. So we already looked at the structure of maltose. So let's assume this is the structure of maltose. One, this is the structure of maltose. The structure of maltose. Then this maltose formed by glycosidic bond. So this is maltose made of 2 glucose sugar units. So you have another. So you're going to have another maltose here. Another one. So we have another one here. So you've seen. So this is 1 to 4 glycosidic bond. So this is amylose. So this is just the structure of amylose. I haven't put some other additional information because we already looked at the structure of maltose in the previous video, so you know what to put here. Here you may have something. Yeah, here you have oxygen, of course, and you have oxygen, of course, and here we have oxygen, yeah. So you're going to put some other additional atoms here, hydroxy, hydrogen. So this is the structure of amylo amylose, I mean. So this amylose can be broken down by addition of water, just the way we did the other ones. So you can add water or remove water, which is condensation and hydrolysis. So let's look at the other one now, the structure of amylopectin. So we've seen to say the structure of amylose is a straight chain. So for amylopectin we have so let's say this is let's assume this is maltose. So this is maltose. So here you are going to have a structure going this way, going this way, going this way, going this way. So we have CH2 here. This is CH2. Remember here you always have CH2OH. So this means that there was hydrolysis here. The water molecule was lost. You removed OH here, and here you removed one hydrogen to form water molecule. So this will be carbon number 6. So that's where you are going to have the alpha 1,6 glycosidic bond. In addition to this 1,4 glycosidic bond. So here it goes this. Yeah. So yeah, so this is the structure of amylopectin. As you can see, it is branched. Amylopectin. Thank you for watching this video. So this is the first video of polysaccharides. So the other video we're going to talk about glycogen, cellulose, and chitin. Thank you for watching. Subscribe to the channel.